Good morning and welcome to another exclusive webinar from Eurotech. My name is Larry Greenwald and I will be the presenter today for this webinar on polygon turning. Before we get started, just a reminder to avoid feedback and background echo, please mute your microphones and be sure to adjust your volume to a comfortable level. I will be accepting questions during the presentation, so to ask a question, just click on the small arrow at the top of your screen, the right-hand corner, and look towards the bottom right for a section to type in your questions. Okay, so let's begin. First of all, let's take an overview of what we do or what can be done with polygon turning. Polygon turning, it's to actually create or simulate milling. So we are able to with polygon turning to create flats, squares, hexagons, and other shapes without actually milling them. The results are we can have faster cycle times, easier setup and control, and we can also cut gears and splines with these. So over here's some of the possible shapes that can be done with polygon turning. And kind of a polygon turning 101, the things you want to start with is number one, you got to realize that the best ratio for polygon turning is a 2-to-1. That means the live tool is running twice the RPM of the main or sub spindle, synchronized together. So in other words, you have the live tool running, say, at 1,000 RPM. And when you go into this mode with the 2-to-1 ratio, the main spindle then would turn only at 500 RPM. Number two, what you want to do is be sure to select a polygon cutter that is made especially for polygon turning. There are many manufacturers out there that are providing polygon turning tools, and we'll get into that in just a moment. Number three is the program, and in the program what we want to do is program the surface feet per minute and the feed similar to finished turning. So in selecting the proper cutter, first we need to know how many surfaces we need to make. So if you look over here, to make 2 flats, we would use a single tooth cutter as shown here. To make 4 flats, we would use a double tooth cutter. And remember, this is with a 2-to-1 ratio. To make a 6-sided hexagon, we would use a 3-inserted cutter. And hexagons, for most of us in turning or with the Eurotech machines with this capability. And by the way, all Eurotech machines are equipped with the polygon turning function as standard. So the most common or widely used polygon turning is making hexes. There's been a lot of, over the last, I'd say, 10 to 15 years, there's been a big move over this, especially in the areas where people are doing things like connectors. A lot of connectors, will have a hexagon in the middle of the part, let's say. So the old-fashioned way is that, we would throw in hex stock or purchase hex stock and then turn the majority of that hex stock away just to leave a hex in the middle of the part. So now with polygon turning, we're getting more and more away from that. More and more people are getting away from that method and going to round stock, which runs much better in 12-foot bar feeders. And probably most of you already have gone through that. And not only does it run smoother, but in some materials, round stock is less money than hex stock. And by running the round stock, we remove the material we need, and then we just come in, say, in the middle of the part where we need to make the hex, and we can use polygon turning to do that. So it's a valuable resource or function to have on a machine. There are many good suppliers of polygon cutters, I said before. One of the manufacturers is available here in the U.S., P.H. Horn. We represent also M.T. Marchetti. They provide also the polygon cutters, a German company, Dieterle, and Schwanog, also another German company. All these companies are represented here in the United States. Like I said, we represent M.T. Marchetti here in the U.S., and those we can definitely provide you with those types of cutters. You can call us. We can give you areas to go to and give you some selections to look at. But also remember that the cutter is one component. The other component is the actual live tool to do this type of polygon or successful polygon turning. Now, can a regular live tool, say Z-axis live tool, be utilized? Yes, it can. However, this one that's shown here is a specially designed polygon cutter, and it's a little bit more heavy duty than your standard say Z-axis live tool. So it's especially designed for polygon cutting, and that's the one we would actually recommend. So obviously, you know, we have two sides of the coin here in successful polygon turning. We have the setup, the selection, you know, of the tools, etc., and then we have the programming. So the setup is also very, very important. Number one, right, we need to select the proper cutter and mount that assembly into the turret. Now, the inserts need to be checked at least once with an indicator to make sure that each insert is at the same height. Now, that's important because if you don't do that on these cutters, if you have an insert that's slightly out or protruding a little bit further than the others, then what are you going to get? You're going to get an uneven hex. If you measure across the flats, you're going to you could end up with some different sizes, and you don't want that. You want your hex to come out as perfect as you can. Also, it will help in the cutting. The other thing is, realize on your setup, you're going to offset this insert or this polygon cutter off of one of those inserts the same you would do as a turning tool. So just pretend that that cutter is a turning tool, and you're going to offset it, if you know, either with your probe or manually, however you do your offsets. If you're going to use the probe, bring the probe out and then rotate the cutter, you know, so that the insert can come in and touch off and take your insert or your offset, I'm sorry, there. Then number three, you're going to offset the Z to the front of the insert, because remember, you're going to treat this polygon cutter like a turning tool. Now here's the program. Here's what the program will look like. Now, what I've chosen here is a 1 1/4 hex. So to program a 1 1/4 hex, this would be the format, right? We start off with a tool call, you know, our work coordinate, coolant on, easy stuff, right? Then first thing we're going to do is I'm going to go ahead and call up the live tool. And in this example here, we're going to call up the live tool at 1,000 RPM, forward or, you know, counterclockwise direction, and P13. Now this example here is for one of our single turret machines. For a double turret or triple turret, that P number would just be different. For instance, on a Trofeo, that P would be P12 instead of P13. So anyway, we start the live tool 1,000 RPM, and the next thing we do is we start up the main spindle at 500 RPM, also counterclockwise direction, P11. Then the code comes into place. We're going to actually now command the polygon turning function, and that code is G251. The P1 is what we call declared. So don't every time you call the G251, you're going to automatically put in a P1. Don't forget that. It's necessary, but it's always going to be P1. And then the Q value is the ratio that you need. Now, we said that the ratio we want to use is 2, a 2-to-1 ratio. So the Q is going to be 2. And then the R R value we have here is R0. The R value is actually a shift. So if you wanted to shift the entire, in this case, entire hex to a different position, you can use R. Now, I've had many discussions with customers over the years on the use of R, and one thing that I can tell you from experience, that it's much easier to go ahead and leave your R at 0, and if you need to shift the position, let's say you're making the hex, and on one of those flats on the hex, you need to drill a side hole, right? So you do a C0 and it doesn't line up. So what do? Well, one of the things you could do is use R here to shift that. But I can tell you from experience, it's not an easy task. It's sometimes a trial and error. So an easier way to accomplish that shift is to actually, in your G54, shift your C axis. So what you would do is just find out, manually rotate the C to line up that flat with your drill. And if you want, you could indicate it, make sure it's nice and flat, and then go ahead and measure C0 at that particular point for your G54, and away you go. Much easier, and much more reliable. So now the next block here is to position, to go ahead and position to get ready to cut the hex. Now I've made it very simple here. So what you do is we're going to wrap it down to an X value of 1.250. Well, the 1.250 matches the hex, right? So that's the distance across the flats, and that's what you want. So our hex is 1.25, so we program our X for 1.25. And then if you have a Y machine, you're going to go ahead and locate your Y at 0, and then position out in front of the part like you would any other tool. So again, be reminded that this is like using a turning tool. So we have X 1.25, Y 0, Z 0.1. We're ready to cut the hex, and now we just go into G1, G98 now. Now we're using G98, which is inch per minute travel. So instead of being in turning mode at G99, we're going to go ahead and do a G98 inch per minute. So to define your feed, right, we're going to be defining our feed in inch per minute. And so then we just go in Z down to the depth that we need to make the hex, and the hex then is produced. And then to pull out, right, away from that, we'll pull above the bar diameter. So we pull out, and you could pull out at a faster feed rate to save a little bit of time. So we'll go to X 1.5 at 50 inches a minute. And then the next block, we're all done. So we're just going to go G0, G53, using a G53 here, which is return to machine coordinate. We're going to X0, Y0, and then a Z pound 552 that many of you, I'm sure, using Eurotechs are aware that we use that for safe Z index position, described by a variable. And then when we're all done, we're going to cancel the polygon mode with a G250. Okay, so simple. Then what we want to make sure we do is stop the live tool with an M5P13, in this case, single turret machine, and then stop the main spindle with a M5P11. And then, if you're in between tools, M01, optional stop. Now here what we're going to do is you're just going to play a short little video here. What you saw there was when it slowed it down, one of those inserts producing that flat, right, as the main spindle rotated around. So there were 3 cutters, and in 2 revolutions of that of that cutter, and 1 revolution of the main spindle, we produced 6 flaps. Here's some notes. If you're programming for the 2-turret or 3-turret machines, like I said earlier, you're simply just going to add an H1 for head 1 or channel 1 for the main spindle, and H2 or channel 2 for the sub spindle. Okay. And number 2, always check your live tool direction to ensure the proper use of the M3 or M4, because make sure your cutter is going to rotate the right way. Make sure the live tool you're using is rotating that cutter the correct way. Many of you already know that with live tools, the first thing you want to do when you get a new live tool in is you want to check the direction of that tool, because it's not necessarily always for M3 going to be rotating in a counterclockwise direction. It depends on the way that live tool was geared. So be careful, use a little caution there. Number 3, once the G251 has been executed, once you're in the polygon turning mode, do not press the feed hold during the cut, as this could damage the live tool unit or the tool itself. So you don't want to do that. You don't want to damage a very expensive tool nor a very expensive live tool. So if something goes wrong during that process, you're better off just letting it go and finish all the way to the G250, because pressing feed hold would cause a worse situation. Also, the live tool should never be programmed above 3,000 RPM. Okay, so there's a limit on the polygon rotation of the live tool, and that is 3,000 RPM. Be sure to adjust your feed to achieve your desired finish, right? Normally 3 thousandths to 8 thousandths per rev. So again, remember, if you go back to the programming, we're programming an inch per revolution. So what you're going to do is you're going to multiply that live tool RPM by the inch per rev to get your inch per minute feed. Okay. Now, the best materials for success in polygon turning are aluminum, brass, most of your non-ferrous materials, and low-carbon leaded steels. Now, that doesn't mean you can't polygon tougher materials, say stainless steel. It doesn't mean you can't. It's just that realize that in polygon turning, you have a severe interruption of cut. So you're in the cut, out of the cut, in the cut, out of the cut, in the cut, out of the cut. So that's very hard on most cutting tools, on most inserts. So a lot of times, depending on what you're cutting, you will choose your inserts accordingly. Most people will use a coated insert to get a little bit better toughness or on the cutting edge, so you get a little bit better tool life. I would absolutely recommend that for when you're cutting steels. We've got customers today, while I speak, cutting stainless steel, 316, 303, 304, doing polygoning. But I can tell you that most of those parts are probably under 3/4 of an inch, meaning that the hex itself is, say, 750 and below. The bigger you go, right, the more severe that interrupted cut is, and that's why you may not have good success on tougher materials on larger hexes. You know what? I'm going to go back to that. I'm going to go back to that graphic here for a minute, if I can get the mouse to cooperate. Let's go back. I'm going to go ahead and play this again. That's the cutter. You notice this cutter's got 4 inserts in it. That's because you could, that one's from Schwanog, I think. This video is provided by Schwanog. And here you see it cutting the hex. And here's what I wanted you to really focus on and see. See how that's coming over? And again, it'll show it again. 1, 2. Okay. Oh, somebody, hang on here, I'll get back to, somebody just asked what was the extra non-cutting insert for. That's a good question. That extra insert, let me see, show you something else here. Let me get to this, and then maybe I can explain a little bit better. That extra insert, that particular cutter from Schronog that was displayed there, is where you can switch from using one cutting edge, right, one insert, or two inserts, or three inserts, and I think that's it on that particular one. So you can pocket, if you looked at that cutter, let me go back again. And I'm having trouble with this mouse. Let me see. What am I doing? Oh, there it is. Okay. Okay. So I don't know if you can see this, but you've got one insert. Well, these are the different pockets. You got 1, 2, 3, 4 pockets. So if we just had one of these inserts sticking out, right, that would produce, at a 1-to-1 ratio, would produce one flat. At a 2-to-1 ratio, that would produce two flats. And then if we had the inserts positioned 180 degrees out from each other, that would produce, at 2-to-1, would produce a square. And then if we have the three inserts 120 degrees out from each other, that would produce the hex. So let's get back. Does the diameter of the cutter matter in any way? Not really. No, it doesn't. Not really. All you want to do is you want to make sure you have the proper clearance. The other thing in selecting your cutter, I can tell you from experience, is those manufacturers that I gave you earlier that are making specific polygon cutters, most of those companies, it's a special cutter because it's weighted and balanced specifically for polygon turning. So I've had customers before try to make their own, and they've been successful, pretty successful in doing, say, brass or aluminum and things like that. But in tougher materials, very, very difficult to get a good result if you don't use the right cutter. So, yeah. So the diameter really doesn't have a great impact on the polygon turning. So in other words, you use a 3-inch diameter or 2-inch diameter or 1.5-inch diameter, really doesn't have that much bearing on it. Here on this chart here, what I wanted to show you here is the different polygons that, say, are most or more typical. Here's a single, if you wanted to make a single edge, I can tell you from experience, that's a ratio to do that. It would take one insert at a ratio to 1-to-1. I could tell you, I don't even really, would never even consider doing that. It says right here, not suitable, heavily convex. So you're not going to get a good result. So if you need to make one flat on the part, you're much better off milling it and not trying to polygon turn it. However, for two flats, right, 1-to-1, again, not suitable, a little bit too convex, but a 2-to-1 ratio, very suitable, and a little convex. All right, so that would be one insert at a 2-to-1 ratio to make two flats. To make three, or to do a triangle, again, from experience, I've not had seen good results on a triangle. So that one I personally would pass up on. But going down to the square, very, very suitable at 2-to-1, two inserts, 180 degrees out. To do the pentagon there, no. Again, from experience, not very suitable. I would cross that one out. Hexagon, absolutely, right? 3 cutters, 120 degrees out, ratio 2-to-1, very suitable, a little convex. And what they mean by a little convex is, if you were to put a square up there and look at it, you would notice that it's not perfectly flat. By how much? There's a formula you can apply, and find out if anybody's interested in that. I could send that to you. Just email me. But basically, what it is, what I've seen from experience, say that 1-250 that I just gave you, you'd maybe have, you know, a half a thou on the ends at the very most, where it'd be a little convex. So not a big deal for wrench flats, for connectors. Most connectors, it's not a problem. Sometimes in the aircraft industry, there might be a flatness call out on that, but for most other things, it's well suitable to polygon turn it. And then here then is an octagon where you can use 4 inserts at a 2-to-1 ratio, and you could make a octagon. All right, let's look over. So other possibilities for polygon turning, other things to explore once you're looking at prints and you're looking at doing other things. You can create gears and splines using the polygon function with the G251. And there's a little example over there of a live tool with a gear hop. So we can hop gears, we can hop splines, and we have all this stuff written up. If you're looking for more information on how to do this on your Eurotech, again, email me at larryg@eurotechelite.com, and I'll give you information on how to set this up and get this going. Another unique thing that you can do, if any of you out there have a Rapido, our fastest little machine in our whole lineup, a very, very impressive machine, and you see here in this lower picture here a polygon milling attachment for the Rapido on the subspindle. So the subspindle cap, the collet cap, is actually a polygon cutter, and you see an insert here, and then the other inserts hidden there behind the part. But on the Rapido, because the subspindle actually is an X3Z3, right? You can use that cap, that polygon cap, to come in and produce polygons on the main spindle. And we have a little video on our website of that being shown. So if you have any interest in that, if you have a Rapido and that's something you want to explore, you know, again, you can contact us for more information. Anyway, that wraps it up. If you'd like to ask any questions over the air, go ahead and I'll unmute the microphone. Anyway, guys, thank you all for taking out the time today to learn more about polygon turning. If you do have any additional questions, you can always contact me by phone or by email. And thank you very much, and goodbye until next time.